couple of things that we do to make sure that the platform is secure. I already mentioned some of them on a more application level. First of all, our whole runtime environment consists of about, I think, 14, 15 services that run together to provide all the functionality. Those services all run on an internal network. And there's only one service that has access to the outside world, and that's Nginx, which is a common third-party software. That is configured as what's called a reverse proxy. So all requests through port 80 and 443, which is normal HTTP and HTTPS, arrive at Nginx first. And only if Nginx trusts the request and knows how to forward it to one of the backend services, the request gets forwarded. So that minimizes the attack surface. So there's no way to directly access a lot of the internal APIs. Then to move to the third bullet point, even inside the internal network, we disabled all network traffic by default. And then we started to whitelist exactly which service has access to which other service through which port. This is all TCP connections, most of the time HTTP connections. So we made a complete list of all the possible connections between the applications. This is best practice, but to be fair, it's not yet very common. I see a lot of scenarios where if you look at the schemas, you see what's called a DMZ, which is in front of the internal network, and then inside the internal network, all the services are open for all the other servers. Even if there are firewalls installed on the servers, that just limits the port. So that, for instance, if you have a database server, only the database port is available, but still it's available for all other services. We made a complete whitelist and very explicitly said, well, this service can communicate to this service, but not this service. But we went even further. All communication between these services internally use signatures. So every API request is signed with a shared secret. Why is this important? This is important to prevent a whole class of security risks where you, as builders of applications, you can use a web request node, an HTTP request node. And this HTTP request node is invoked from within the WAM runtime environment. So this HTTP request node, in theory, has access to all the internal APIs of the WAM runtime environment. So if we were naive, we thought, well, this is not accessible from the outside world. A malicious user can just create a WAM project, try to invoke the internal APIs of the WAM runtime, and, for instance, get access to a database or even delete a portal or something like that. So to prevent that, we made sure that all the internal APIs are secured by using signatures. If you look at the new platform, the Kubernetes platform that we are using, we are, of course, also using all the best practices in terms of security for Kubernetes, which, for starters, means that in Kubernetes, everything runs on Linux systems, but we use a very minimal Linux distribution where almost everything is disabled by default. So normally if you install Linux, it's an installation that it takes a couple of 100 megabytes, and you get all these utilities like curl and OpenSSL and all these small utilities that you can use. This distribution, I believe, is only 4 or 5 megabytes. That's it. Everything is removed, and if you want to use something, you have to explicitly add it to the package. We do regular updates. We use this Alpine Linux distro. That's the minimal Linux distro, and it's in my experience updated at least once a month. So we also actively make sure that we always build on top of the latest versions. Then all our applications are running as non-root users, which even in a worst case scenario, somehow someone is able to execute some random code, then still this application has very limited user rights. We whitelisted the network traffic. We made sure that almost none of the common libraries are available. We make sure that everything is patched on a regular basis. And the applications are running on non-admin, on non-root users. On top of that, we made the whole file system of all our servers completely read-only. So there's, for instance, no way to change configuration files or to add something. And of course, a lot of computers need some space where they can actually write some data. And for that, we explicitly defined, well, the root file system is read-only, but this specific folder you have write access to. And that's not just for this user or this application, that's for the whole system. The rest of the disk is read-only. Even if I log in as an administrator, I can't change a thing. And of course, we make sure that all our disks and file systems are encrypted by default. I believe I've told everything I wanted to tell. Are there any questions? Yeah.
Yes, do we also have access to the PowerPoint?
I believe we can share it. Yeah. No, security by obscurity is no security. Yeah, we can do that.
You still run monthly pen tests,
or? We still run
pen tests at all on the runtime environment?
Yeah, we have regular pen tests. Yeah, yeah. By the way, most of those pen tests they all test the same things. They all test against the same common pitfalls that you see in for instance, they try to see if a MySQL database is available publicly or if some common administrator tool is used. It's the pen tests that actually require manual labor. There's a difference between automatic pen tests and manual pen tests. And the automatic pen tests, they can't find anything at all. It's just like a couple of million requests that we notice, but there's no chance that they can penetrate the system. If you're talking about this manual pen test, then oftentimes it's not just WAM that's tested, but also the applications itself. So that the testers, for instance, get credentials to log in and go through every screen and see if they somehow can hack the system, which results in a lot of funny data, like fields that contain all kinds of scripts and things like that.
So when it comes to, let's say, the field type file,
Yeah.
when we try to upload a file, does WEM have an internal security check on whether that file is corrupted or has any viruses? Or?
Not yet. Not yet. We have implemented the feature, and then I totally forgot about it. But it's on my list again to introduce in the next version.
Okay.
Yeah.
Thank you.
And then it's optional to enable it, but it's enabled by default. By the way, in WEM itself, what you upload, it will and can never harm the system. We don't save it as a file. We don't store it in any way where it can be executed or can do any harm. What you're mentioning is basically preventing other users from harm when they download the file. Yeah. By the way, I have seen existing projects where this was solved by using a third-party API where you can set the file to check for viruses. But we added a service to our runtime environment, which is basically an open source service that has that uses an open source database that's included into the distribution of the runtime that we update regularly. Yeah, good question. Was everything clear? Oh.
Yes.
Yeah. Then I thank you for your time.